Exponential and logarithmic functions. What is an exponential function? We remember from chapter 1, p of 0 times a raised to the t, or p sub 0 of e raised to the kt or rt. What is the logarithmic function, log of x or natural log of x? And we talked about that in chapter 1. So today we're going to find the derivative of both a to the x and e to the x. So I'm using an example to help us, and using the difference quotient to come to a conclusion or reach a conclusion about how we find the derivative. So I took f of x, or f prime of x, is equal to the limit as h approaches 0. Now this means that our h value is going to be very small. In this case, we're going to let h equal 0.001. So just bear with me a minute. We are taking 2, raising it to x plus h minus 2 to the x over h. Then we're separating this because this says these two are added together. That means I can multiply them. So then I'm going to, this is a 2 to the x times 2 to the h minus 2 to the x. So we have a common factor here, so we're going to factor that out. And then we have 2h, 2 to the h minus 1 all over h. So now I'm going to put this part together. And what does that part do when I let h equal 0.001? And when I plug that into my calculator, I get 0.6934, which of course that's rounded. That is not the exact value, but it's a very close value. When you plug into your calculator natural log of 2, you get that value. So what this means is that the derivative of 2 raised to the x is equal to 2 to the x times the natural log of 2. And we can do the same thing with 3 to the x, letting h equal 0.001, and we have 1.0992 is our value. And then natural log of 3 is equal to that. So the derivative of 3 to the x is 3 to the x times natural log of 3. E to the x is very easy because e to the x is e to the x. So here are the rules. The derivative with respect to x of e to the x is e to the x. The derivative with respect to a to the x is a to the x times natural log of a. Natural log, the derivative of natural log of x is 1 over x. And for e to the kt power, the derivative will be k times e to the kt. This e raised to any power does not change, but what you're doing is taking the derivative of the numerator, so that's why we have the k there. So let's do a problem. The population equation of a nation is P of t is equal to 6.0944 times 1.003 raised to the t million people since 2008. At what rate is the population growing at the beginning of 2010? So we want a rate. Anytime you hear what rate, that means I'm looking for a derivative. So in this case, we have the equation. We want the derivative. The derivative of the population equation with respect to t is equal to d divided by dt of this function. So as we learned before, that this value, 1.003 raised to the t, that's what we're looking for. That's what we have to take the derivative of. This value stays as it is. So now I'm going to take the natural log of this value times 1.003 raised to the t. These two are not whole numbers, but real numbers. So I can plug that into my calculator and get a value. And so it's 0.0183 times 1.003 raised to the t. So that means that to find the rate at the beginning of 2010, which is 2 years later than 2008, we're going to find the population, or the derivative of the population function at 2. And that's going to be 0.0183 times 1.003 raised to the second power, or 0.01841 million people at the beginning of 2010. Now that number seems kind of small, so we're going to multiply by a million to get 18,410. The population is increasing, or did increase, by that many people per year. Now let's look at a few other problems. If we have f of x is equal to x to the third plus 3 to the x, then we have used the rule that we learned in the derivative section, where you take 3 times x and then subtract 1 from this exponent, and that gives us 3x squared. Plus 3 to the x, now we know that is 3 to the x times natural log of 3. So anytime you see like this 10 to the x, you're going to have natural log of 10 times 10 to the x. My advice is to put the 3 to the x or the 10 to the x in front of the expression, the natural log expression, because then you can make sure you don't get it in the wrong place. So I am going to move this, so this is 4 times 10 raised to the x times natural log, and then I'm going to delete this one, minus 3x squared. E to the 0.7t is going to be e to the 0.7t, but now we're multiplying by 0.7. Find the tangent line equation when you're given y is equal to 3 to the x at x is equal to 1. The first thing you need to do is find the point. So the point is 1, 3. 1 was our x value, input value, 3 is our output. Y prime is natural log of 3 times 3 to the x. So now we have natural log of 3 times 3 to the 1. So the slope at 1 is 3.2958. So now I'm going to use the tangent line equation, and I have 3 plus the derivative times x minus 1, and that gives me this equation. However, we can simplify that to be y is equal to 3.2958x minus 0.2958. Find the equation of the tangent line when you have a continuous function. We know so we wanted x is equal to 4. We plug in 4 and to our original equation to find our point. So the point is 4.4933. Then we find the derivative, plug the value of 4 in to find our slope is negative 0.8987. Use that to find the natural log, not natural log, the tangent line equation. Going back to demand curve for a product, this is some money. Q is equal to F of P is equal to 10,000 times E raised to the negative 0.25P, where Q is the quantity sold and P is the price of the product in dollars. So we have our function. We find the value for our function by plugging in 2. Quantity should be rounded to the nearest whole number. So what does that mean? That means that when the price is $2, the quantity sold will be 6,065 items, or if you want to write that as 6,066, I'm fine with that too. The derivative is 10,000 times negative 0.25, that gives me negative 2,500. And then times E raised to the negative 25P. So now we have here, this should be negative 2,500 times E raised to the negative 0.25 times 2. That gives me negative 1516. So I'm going to plug that in just to make sure it is correct. Negative 2,500 times E raised to the negative 0.25 times 2. And I get negative 1,516 is the slope at that point. This means that if the price increases by $1 from $2, so now we're at $3, then the quantity decreases because we have a minus sign, 1,516 items for an additional dollar charged.